While public attention is fixed on AI software, the hardware has quietly reached a tipping point. With facilities like RoboFab Online and Tesla targeting 100,000 units, 2026 marks the shift from experimental prototypes to mass-produced inventory. We aren't just watching robots learn, we are auditing a revolution in manufacturing. Basically, the research phase is officially dead and the shipping phase has begun.
In 2026, robots don't just learn to walk, they get shipping labels. We aren't predicting the future anymore, we are auditing a supply chain. Here's the math of the revolution. When you combine the confirmed factory outputs of the major players, we are looking at a global production capacity exceeding 140,000 humanoid units coming online in 2026. This isn't a pilot program, it is infrastructure. Let's start with the dark horse moving the fastest, XPeng. While others are refining prototypes, XPeng has deployed their iron humanoid directly into the P7 electric vehicle assembly lines in Guangzhou. But look closer at how it moves. The iron unit features 60 joints and over 200 degrees of freedom. To put that in perspective, while a human body technically has hundreds of joints, functionally, iron has achieved near parity with human industrial range of motion. It uses a proprietary eagle-eye 720-degree vision system. That's double the peripheral awareness of a human worker, allowing it to navigate chaotic factory floors without blind spots. They aren't building dozens. XPeng's 2026 target is mass production, aiming to ship these units into retail environments by year's end. Then there's Tesla, and the numbers are staggering. Musk's internal target is to ramp up from 5,000 units in 2025 to a production capacity of 100,000 units in 2026. But the real story is the actuation. Tesla has moved to custom planetary roller screw actuators, essentially the muscles of the robot. These provide a lift capacity that defies their size, allowing a 56-kilogram robot to handle payloads that would strain a human. The technical leap here is the end-to-end neural net. Unlike older robots that were coded to walk, Optimus runs on visual inputs converted directly to motor outputs. It has 11 degrees of freedom in the hands alone, giving it the tactile precision to handle an egg or a power drill. This isn't just movement, it is high-fidelity manipulation verified by tactile sensors in every fingertip. If you think this is all hype, look at the hard manufacturing data from Agility Robotics. They have completed RoboFab in Salem, Oregon. This is a 70,000 square foot facility with a confirmed hard cap capacity of 10,000 robots per year. Their robot, Digit, ignores the humanoid aesthetic to focus on pure logistics utility. It features backward bending legs for superior stability and a 35-pound payload capacity designed specifically for standard industry totes. It doesn't need to look like you, it just needs to work harder than you, and it's shipping now. Then there's Figure AI, matching that pace with their BotQ facility targeting 12,000 units annually. The technical enabler here is onboard compute. The Figure 2 packs 3 times the inference power of its predecessor. They've eliminated external wiring. Integrated cabling runs through the joints, mimicking a human nervous system. This allows for fully autonomous operation for up to 5 hours on a single charge. With 16 degrees of freedom in the hands and commercial deals with BMW, they are targeting unstructured environments where the robot has to make decisions, not just follow a track. The headline isn't that robots are improving. The headline is that they are being manufactured, crated, and freighted. We have moved from can it walk to how many can you ship? 140,000 units, 200 degrees of freedom, end-to-end neural brains. 2026 isn't the year robots arrive, it's the year they become inventory. Thanks for watching, and if you're interested in more content just like this, then don't forget to subscribe and leave a comment. Let me know what you think.